Hey guys, Mr. Burns here with your video for lesson 1.6, common factors and multiples. By the end of this video, I want you guys to be able to find the greatest common factor and the least common multiple of two whole numbers. Okay, remember that factors are numbers that can be multiplied together to find a product. In example 2 and 4, for example, 2 and 4 are factors of 8 because 2 times 4 equals 8. The greatest common factor, or GCF, of two or more numbers is the greatest factor that is common between the numbers in a set. The greatest common factor can be used to solve problems involving real-life situations. One method for finding the greatest common factor of two or more numbers is to create a list of the factors and each number and then locate the greatest number that appears on both sides, or on both lists. So on example number 1 here, it says find the greatest common factor of of 24 and 32. In the solution there, it says create a list of each number. So in this example, you'll notice that these are the factors of 24, and if you'll notice that all of the factors are listed from the smallest factor to the greatest factor. And they do the same thing here with the factors of 32. They start off with the smallest factor and the greatest factor. Okay. Later on, I am going to introduce you guys to a little method, kind of a twist on this method. But for all intents and purposes, for right now, I'm going to leave it as it is. Okay. In the green box, it says each of the numbers in the list is a factor of 24 because it divides evenly into 24. Then it says locate the number that appears on both lists. Those are common factors. So the common factors are 1, 2, 4, and 8. Out of those factors, which one is the greatest? Which one is the biggest? That would be 8. Okay. In example number 2, it says Reagan Middle School students were asked to sit in equal rows for the assembly. There are 98 6th graders and 84 7th graders. The teachers did not want grade levels sitting together, but the rows were supposed to be as wide as possible. How many students should sit in each row? So the solution says, list the factors of each number, which is what they did for both the 6th graders and the 7th graders. Okay, and so they listed the factors of 98, which are listed there. And they also wrote down the factors of 84, which are listed there as well. Then they highlighted the common factors, right? So the common factors. So what I like to do is I like to list the common factors. So 1, 2, 7, 14. And out of those factors, which one is the GCF? Which one is the greatest factor they have in common? That would be 14. Okay, so 14 students should sit in each row. All right, here we go. On to the next examples. Okay, a multiple is the product of any given number and a whole number. The least common multiple is the smallest multiple, not 0, that is common to two or more given numbers. So factors are small, okay, and multiples are large. So multiples get larger. In example number 3 here, it says list the first 5 positive multiples of 3 and 6, and then find the least common multiple. So find the smallest multiple that they have in common. So what they do here is they list the multiples of 3 and 6. So 3, 6, 9, 12, and 15, those are all the first 5 multiples of 3. And then they list the first 5 multiples of 6. So 6, 12, 18, 24, and 30. So out of the multiples that they listed, which one is the smallest? Well, what I like to do again is I like to list the multiples. So they have a 6 in common, and they have a 12 in common. But out of those two multiples that they have listed that they have in common, which one is the smallest? That would be 6. Okay, so that's multiples. Another strategy for finding multiples is to use a number line. A number line can be used to mark off multiples of two or more numbers until at least the least common multiple is reached. On example number 4, it says, today, Deanna and Kai volunteered together at the senior center. Deanna volunteers every 4 days. Kai volunteers every 5 days. When will they be at the senior center together? So the solution says to draw a number line to represent days. Mark every multiple of 4 to represent Deanna's volunteer days using a square. And then mark the multiples of 5 for Kai's days using a circle. So on this number line, you'll notice that it starts off at 0 days, and then it goes up by 1. So it goes up by intervals of 1 until they get to 20. Why they chose 20, I don't know, just because, right? And then the top part of the number line represents Deanna's volunteer days, and the bottom part of the number line represents Kai's days. So with Deanna's days, they're going up by 4. So 0, 1, 2, 3, 4 square. And then 1, 2, 3, 4, 8. 1, 2, 3, 4, 12. 1, 2, 3, 4, 16. And then 1, 2, 3, 4, 20. And then they do the same thing with Kai's days, but they go up by multiples of 5. So 5, 10, 15, 20. It says the multiple of 4 are in blue squares, and the multiples of 5 are circled in red. The first number that has both a circle and a square around it is 20. That means the least common multiple of 4 and 5 is 20. So Deanna and Kai will volunteer together 20 days from today. So that's one way to do it, is with the number line. Me personally, to save space and time, I like listing. I like example number 3, and I'm probably going to stick with that as I go through the worksheet. Okay. All right. Moving on to the next page. Okay, so here we are on lesson 1.6T, the worksheet here. So common factors and multiples. So for number 1, it says list the steps to find the greatest common factor or GCF of 4 and 6. So for part A, it says list the factors of 4. So the smallest factor of any and all numbers is 1. Okay, the largest factor of any number is the number itself. So remember, factors, so write this down. Factors, okay, are small. Okay, the largest factor of any number is the number itself. The smallest factor of any and all numbers is the number 1. So here's one thing you can do. So what's another number that will divide 4 evenly? That would be the number 2. Okay. So for part B, it says list the factors of 6. Well, the smallest factor of any number is 1. The largest factor of any number is the number itself. So I'm going to put it all the way over here to the right. Going up from 1, what's the next smallest factor you can think of that will divide 6 evenly? That would be the number 2. After the number 2, what's the smallest factor that you can think of that will divide 6 evenly? That would be the number 3. So it says circle the common factors of 4 and 6 in part A and B. I'm not going to circle them. I'm going to list them. So, and there's a reason why. So they have a 1 in common and they have a 2 in common. So then it says the largest factor that is circled, okay, which is 2. So therefore, this is the greatest common factor of 4 and 6. There's another way that I like to list factors. I like to list them like as a multiplication problem. So if I go 4, so 1 times what is 4? That's 4. 2 times what is 4? That would be 2. All right, and then with 6, I'll do the same thing. 1 times what is 6? That's 6. And then the next one, 2 times what is 6? That's 3. All right, so I like to list my multiples like my factors like this. Sometimes that works for some kids, sometimes it doesn't. So I'm going to show you guys that method again when we get to numbers 2, 3, and 4. All right, so let's see. Numbers 2, 3, and 4. It says find the greatest common factor for each set of numbers. So here we go. So with number 3, I'm going to go ahead and list the factors. Here we go. So for 3, the smallest factor of any and all numbers is 1. The largest factor of that number is 3. Is there any other number in between 1 and 3 that will divide 3 evenly? The answer is no, there isn't. So you're done. Let's take a look at 9. 9. The smallest factor of any number is the number 1. The largest factor of that number is the number itself. Is there any other number in between 1 and 9 that you think that will divide 9 evenly? Will 2 do it? Let's see, 2, 4, 6, 8, 10. Nope, 10 is too big. Well, 3, 3, 6, 9. Yep, 3 will do it. 3 goes into 9 3 times. Is there any other number in between 3 and 9 that will divide 9 evenly? Let's see. Well, 4, 4, 8, 12. No. 5, 10. Nope, 5 won't do it. Well, 6, count by 6 is 6, 12. Nope. Will 7 do it? Let's see. 7, 14. No, too big, too big. 8, will 8 do it? 8, 16. No. So guess what? There aren't any other factors, okay, of 9. It just has 3. 1, 3, and 9. What are the common factors? They have a 1 in common, and they have a 3 in common. Out of those two factors, which one's the biggest? That would be 3. So that's the greatest common factor. Okay, for number 3, here we go. So choose a different color. So we've got 6. What are its factors? 1 and 6. Is there any other number that will divide 6 evenly? After 1, that's 2. After 2, what's the next smallest one? 3. Will 4 do it? 4, 8. Nope. So guess what? I'm done. Moving on. 8. What's the smallest factor? 1. What's the largest factor? 8. What's the next smallest number after 1 that will divide 8 evenly? That would be 2. After 2, will 3 do it? Nope. Will 4 do it? 4, 8. 4 will do it. 5? No. 6? Nope. 7? 7? 8? Yes. 1 time. So out of those factors, let's list the common ones. 1, 2, and that's it. Out of those, what's the greatest common factor? That would be 2. Okay, on number 4. Number 4, I'm going to change up just a little bit. 12 and 18. I'm going to list what I call their factor pairs. So here we go, 12. So 1 times what is 12? 12. 12 is an even number, so 2 will go into it. So 2 times what is 12? That's 6. Will 3 go into 12? Yes. So 3 times what is 12? That's 4. Okay. And guess what? I'm done. 18. 1 times 18. If you guys start seeing a pattern here, not a bad thing, not a bad thing. Here we go. 2. 18 is even, so 2 will divide it evenly. So 2 times what is 18? That's 9. Will 3 go into 18 evenly? Yep, it will. So 3 times what is 18? That's 6. Is there any other number in between 3 and 6 that will divide 18 evenly? No. So you're done. So let's go and list the common factors. So they have a 1 in common. They have a 2 in common. They have a 3 in common. And they have a 6 in common. So out of those 4 common factors, which one is the biggest? That would be the number 6. All right. So for 5 and 6, it says list the first 5 non-zero multiples of each number. So we're switching gears here. We're going from factors to multiples. Okay, so remember that multiples get bigger, factors are smaller than the numbers that you're dealing with. So here we go. The first 5 multiples of 5. So 5 times 1 is 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. For number 6, what are the first 5 multiples of that one? 9 times 1, 9. 9 times 2, 18. 9 times 3, 27. 9 times 4, 36. 9 times 5, 45. And that's all you had to do there. That's all that they were asking you to do. So list the first 5 multiples. Number 7. So it says find the least common multiple, or LCM, of 4 and 8. So for part A, list the first 5 non-zero multiples of 4. So count out by 4s. So 4, you always start with the number itself. So 4, 8, 12, 16, 20. Okay, and then, let's see, the first 5 multiples of 8 are 8, 16, 24, 32, and 40. So what are the common multiples in your list for the numbers 8 and 4 and 8, that would be 8 and 16. So which of the numbers in part C is the smallest? This is the LCM, or least common multiple, of 4 and 8, and that would be 8. Okay, on to the next page. Okay, so for numbers 8 through 10, it says to find the least common multiple, or LCM, for each pair of numbers. So let's go ahead and do that. So for 3, I'm going to list the first 3 multiples. So 3, I've got 3, 6, 9, 12, and 15. For 5, I've got 5, 10, 15, 20, 25. What are its common multiples? The common multiples are 15. So guess what the LCM is? 15. Let's go ahead and do this same thing for number 9. For number 9, we're going to list the first 5 multiples of 5. So 5, 10, 15, 20, 25. For 6, let's list the first 5 multiples. So we've got 6, 12, 18, 24, and 30. What multiples do you see that they have in common? Let's see here. I don't see any. So guess what we've got to do? We've got to list a couple more. So let's list 2 more for 5. So I've got 30 and 35. For 6, I've got 36 and 42. Do you say a common multiple now? So what multiple do they have in common for 5 and 6? That would be 30. Okay, so I ran out of room there, didn't I, for number 9. So for number 10, I'm going to list it down there. So let's go ahead and list the first 5 multiples of 8. So I've got 8, 16, 24, 32, and 40. For 10, I've got 10, 20, 30, 40, and 50. Out of those multiples, what do they have in common? Well, they have a 40 in common. Do they have anything else? Not that I see. So for number 10, the least common multiple is 40. All right, so here we go. On to number 11 and 12 and 13, which are all story problems. So for number 11, it says Jordan has 20 drama DVDs and 25 action DVDs. He wants to arrange them on shelves so that the 2 types of DVDs are separate. He wants as many DVDs on a shelf as possible, but an equal number of DVDs on each shelf. How many DVDs should he put on each shelf? Sounds kind of like me, a little OCD. But hey, what can I say? Okay, so the factors of 20 are, what's the smallest factor of any and all numbers? That's the number 1. What's the largest factor of that number? The number itself. So here we go. So after the number 1, what's the next smallest factor of 20? That would be 2. After that, what's the next smallest factor of 20? That would be 4. And then 5. And then 10. Factors of 25, 1 and 25. And after 1, what's the next smallest factor of 25? That's 5. Anything else? No. So what are the factors? It's got a 1 in common, and we've got a 5 in common. Out of those 2, okay, which one's the greatest? That would be 5. So for part D, Jordan should put 5 DVDs on each shelf. Dun, 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 dun. Number 12. Number 12 says, Sarah washes light clothes every 2 days. She washes dark clothes every 4 days. She washed both light and dark clothes today. How many days until she washes both light and dark clothes again on the same day? So here we go. So it says find the least common multiple of the 2 numbers in this problem. So every 2 days, let's do this. Every 2 days and every 4 days. So list the first 5 multiples of 2. So I've got 2, 4, 6, 8, 10. And then for 4, I've got 4, 8, 12, 16, and 20. So what multiples do they have in common? Well, they have a 4, they have an 8 in common. Anything else? No. Out of these two multiples, which one is the smallest? That would be the number 4. So Sarah will wash both light and dark clothes again on the same day in 4 days. That reminds me, I got some laundry to do myself. Dun, 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 dun. Number 13. 13 says TJ visits his neighbors every 8 days. He visits his sister every 6 days. They must live in the same town. He visits his neighbors and sister today. How many days until TJ visits both his neighbors and his sister again on the same day? So in this case, they're asking us to project out. So whenever they ask us to project into the future, we're listing multiples. So let's list the first 5 multiples of 8. That would be 8, 16, 24, 32, 40. And the first 5 multiples of 6 are going to be 6, 12, 18, 24, and 30. So out of these, let's go ahead and circle the multiples they have in common. I see 24 and 24, and I don't see anything else. So if I don't see anything else, guess what? That's the smallest multiple they have in common. So the final answer is 24 days. So on every 24th day, TJ will visit his neighbor and his sister on the same day. What a good neighbor TJ is, and what a good brother. Aw, that's just awesome. Hey, you know the drill. If you need any help, make sure you ask your teacher. If your teacher's not there and you need some help, come and see me, and I'll be more than happy to confuse you. That's all I got. Mr. Burns out.